Yeah, I think we can go ahead and get started today.
Okay, hello, I'm Ethan, just doing a quick intro before we start. A couple reminders, check Slack. It's our super main form of communication, and we send stuff in there, so that's where everything is. Membership dues, there was a message in Slack about that, and a page with more information about that, but please pay it if you can, just because it helps with our finances on the tax side of things. First credit form was also sent in Slack. There's info on that message. Pumpkin patch on Saturday. If you can come, that'd be super cool. Info on Slack. And there are rides too if you don't have a car. So that's covered. And then Bootcamp project. I don't know how much you talked about.
No, I can keep going. I can take it over. So yeah, Bootcamp project, just the first milestone is going to be due this Friday. Hopefully you guys have started it by now. I know I've seen a few pull requests up from people. If you can't quite get it in by Friday, just try to get it in by the end of the weekend. We say Friday, and we know that's kind of an inconvenience to students, but that gives us time to review it so you guys can get feedback on your code and get started on the next milestone at an appropriate time. So sorry about the inconvenience for it being on Friday, but logistically that makes more sense for us. And yeah.
Could I add something?
Yeah, go for it.
And yeah, I know the project is extra work, but we really ask that you kind of take it serious, because when you work with a nonprofit, we want to deliver a good product to them. So this project is kind of where you learn. So yes, that's the reason we do it. It's not just for busy work. Little philosophy there. But yeah, thank you.
Yeah. Are we good to get started?
I think so.
Sweet. So welcome to the third bootcamp session. It's kind of weird that it's already the third one. It feels like still don't really know what's happening, and it feels like very early, but we're making good progress so far. So today's agenda, we're going to learn about some JavaScript, and especially writing code in JavaScript, what functional programming is, and hopefully today we'll have time to cover how you can combine our JavaScript with our HTML and do some pretty cool things like make our websites more interactive. And yeah, as we we're talking about, the first project milestone is due tomorrow at midnight. And it is really important that you guys do get those done. They will prepare you for the projects. I know last year that there were some people who didn't get their projects done, and that just kind of some people still had productive work on their projects, and others felt like they had a lot of catching up to do. Either way, it's just good to do. And the whole goal of Bootcamp is to prepare you for these project teams. So doing it is the kind of best thing you can do to actually kind of increase the impact you can have. And then moving on to the schedule, here we are in this third session, JavaScript basics. JavaScript's a large topic. We're going to cover it in more detail and some more advanced things you can do with JavaScript tomorrow. And then we kind of get into some stuff that a lot of people probably haven't seen before. We'll move, and it'll start going really fast after this fourth session. But yeah. So our usual Kahoot, it's going to be on Git.
Yeah. And do you want to have people partner up?
Yeah, if you could partner up, that'd be great. If not, it's fine. Do you think it's an advantage to be with a partner or be by yourself? Honestly, yeah.
First one in. I wonder where they got that name from. I mean, where did they get the name from?
Because
Google's like a prefix. You can't use a lot of Yo, Ryan and Ryan.
Oh god, they're a good team.
I highly doubt it. I think I heard some good words. You should join.
I kind of haven't seen it. I kind of want to join, but then if I lose, it just looks bad.
So we have significant.
Yeah.
I tried to cover stuff that we also like skirted over, so people would like, yeah, it's a little learning curve. Some of the stuff I watch, if they were paying attention.
Like, I don't know, what's the hardest thing? What's something we skirted over?
It was, I feel like people aren't going to recognize like the main branches, like the branch that's like first in the game.
Yeah.
And then I have quite a few that are like, do you get push or do you get pull?
Yeah, I think those are gonna get people. And I think the one that's
The one with the order. That one, yeah, that one you just have to pick. Some of you just have to.
I think we need to figure out a way to send announcements to everybody without spamming them, like in general. Because we gotta like remind people about bootcamp and say like, hey, you guys should come.
I mean, ideally we could put that in bootcamp up, but I don't think it's.
Yeah. Yeah. I don't know, I kind of just like having to talk.
A little bit.
Yeah.
It gets people to know. So, it means 15.
15.
I guess.
About.
Max and 18.
The rate of it dropping.
Do we have anyone interested?
No. I think people just watch the recording.
Yeah, but
Yeah,
I mean, I think it's about 50.
Well, I mean, we'll see tomorrow how many people submit.
What if like not enough people? That would be so bad.
What?
If people like don't complete it, that would be so bad. When we had like 20 people total for all the trucks.
Oh, yeah. No, I think we're gonna, if people fall like a week behind, I think we should reach out to them.
Yeah.
Because like at that point, like you're starting to actually get behind.
Yeah.
It's like you can fall behind a little bit after some point. You might need a bit of a nudge to get back on track.
Alrighty. Are you ready to get started?
Does everyone have a partner?
Or is just everybody in?
Yeah, is that everyone in?
Oh,
Not
all
yet?
good. All right, sweet.
All right, we're gonna go ahead and start the game now.
Yeah, we need the audio.
It only comes off my computer. Yeah, so I can really just crank it up. It's not even coming out.
That branch is kind of tricky. It's like, it's one of those buzzwords where if you're just going quick.
Everyone got it.
Let's go.
Nice.
I'm sure nobody guessed.
It's the individuals.
Oh,
That's a good question.
I would have been
Someone's
speedy.
fast. Someone's fast. Oh, I can hear it.
Oh yeah.
Yeah,
Wait,
where's
try to
that?
get the volume on that thing.
Yeah.
Possibly.
Yeah.
Good stuff.
I guess we're just really good teachers.
You should just have like a word that doesn't even start with repo. Just like reptile.
I mean, you're not wrong. But it's the wrong word.
I can hear like the,
Yeah, I know.
Just too much text.
That's an excellent question.
Yeah.
Oh,
Yeah.
Speedy. Okay.
I can feel like I'm ticking.
Yeah.
I feel like a tactic is kind of to like start at the back.
Yeah.
Oh, okay. If when in doubt, if we run out of answers, we just put branch.
Yeah.
They'll get somebody.
Yeah.
Nice.
Good. Oh, same people on. This goes with one kind of people, I think.
Get push screen.
Almost.
I think touch screen, if you're laptop's touch screen, you might have an advantage.
Yeah, for sure. If you're on mobile,
Yeah.
because you have less distance to cover between the.
Yeah.
This one, this one I think people are gonna.
I can't read it.
You even work.
Okay.
Oh, nice.
That's pretty good.
Will anyone dethrone the
They're
champion?
taking it away.
Yeah.
Oh, nice.
Staging area. It's the right one. Why is that?
Oh,
Oh, really?
I struggled to read that one.
Well, it's 'cause- wait, I think I added an extra word in there. 'Cause it's
What?
From other developers before until we make the pull request.
Oh.
Oh.
It's a close race at the top. 40. Who's gonna bring it home?
They just got a YOLO.
Yeah.
Oh. That's a good one to put last.
There are two right answers.
That's really tough.
It's so good. We got someone in.
So do you have to click both to get it right?
Yeah.
Yeah.
Oh, there's like a multi-select on
Nice.
Oh, okay.
it. Nice.
A lot of people. All right, let's see.
Let's see.
See the
Are they
results.
got it?
All right.
Oh,
Cool.
oh,
Ryan.
Ryan and Ryan.
Excellent. work.
another good performance for them.
Rachel,
Oh.
second place.
Our winners? Congrats,
Yeah,
congrats.
excellent work.
That's-
Pulling it away at the last second.
Yeah.
Weird.
Oh, all right.
Yeah. Yeah, nice job, everyone. That was great. Why?
So screen share.
Yeah. You're good.
All right. All right. Okay. All right, good work on the Kahoot, everyone. It was a good review, so I'm glad that y'all got some information from last week. It looks like people got stuff right for the most part, so it's a good sign. So today we'll move into our next topic. So we're going to be talking a lot about JavaScript today. So kind of before I jump into it, can I get a quick poll? Has anyone in here used Java before? Not JavaScript, but Java? Okay, so we've got some people. So if you have used Java before, I'd like you to forget pretty much everything that you know about Java when you're learning JavaScript. Because as this quote illustrates, Java is to JavaScript as car is to carpet. There's nothing at all similar between them besides they're both coding languages and they both have Java in the name. So they're pretty different. And JavaScript in general is a pretty unique language compared to a lot of other things that you'll have seen. So this might be a bit of a learning curve from anyone who hasn't used JavaScript before, but it's pretty cool once you do learn how to use it and you can do a lot of interesting stuff with it. So first, let's talk about kind of why we're learning JavaScript. So JavaScript is the programming language that pretty much all browsers use. just like the reason we've learned HTML and CSS, it's the industry standard. It's what every full stack developer uses. So it's a technology that you have to know if you want to do this kind of project or you want this kind of career. The only real competitor to JavaScript is Ruby on Rails, and Ruby on Rails doesn't do as much as JavaScript, and it's not as widely used. So really, this is the only thing you need to learn in order to do full stack web development. So what JavaScript is really going to do for you all in your projects and on our project teams is it kind of gives our pages an interactive capability, lets us kind of handle some data and work with numbers, different things like that, and gives functionality to our websites. Because as of so far, y'all kind of made some pretty static websites that look pretty when you move back and forth between pages, but they really don't do that much. So JavaScript's going to change that, and let's actually do something pretty cool with it. So first, we're going to kind of talk about just some basic syntax stuff that comes around with JavaScript and introduce you to some of the new quirks that come with the language. And then we'll go back and kind of do a quick demo to show you what the syntax looks like later. So the first thing in JavaScript, there's two main ways to declare variables. These examples on the screen, let x equal 5 and const y equals 5. So in both these examples, the blue words x and y are going to be your variable name. So that can be whatever you want really. And then the red values are just whatever value that variable holds. Whether it's a number, it's a string, a Boolean, can be anything you want. So let type variables are mutable. They allow you to change them. So if you wanted to add something to 5 in this example, JavaScript would let you, and you can update that value wherever you see fit. And then const type variables cannot be changed. So these are immutable, and you would use this for any kind of constant value in your algorithm or anything that maybe you're comparing every value against. Something you don't want to accidentally update, you're going to use const for. And then JavaScript is a loosely typed language. So this is one of the huge differences between JS and Java is Java is something that's strongly typed. You have to know what type each variable is. And in JavaScript, that's not the case. Both examples you see on the screen, those are like totally complete variable definitions. So we don't have to tell JavaScript whether it's an integer, whether that's a string or anything like that. So you don't have to know ahead of time like what variable types are. This can make it easier to code ahead of time, but it can give us a lot of errors later on. So it's something that we just want to think about when we're developing. And then one kind of side note on variables, if you're looking through kind of like Stack Overflow, different resources, stuff like that, you may see syntax that looks like bar z equals 5 in that example there. That's kind of an out-of-date way that you used to be able to declare variables. It's still valid, but it's going to be essentially the same as let in this case. So just so you all know what that means if you see it. So a quick overview of data types. I'm going to go into a little bit more detail on all these later on. So on this slide, the only ones I'm really going to talk about are the difference between undefined and null. So an undefined variable, as you can see on the right-hand side of that column, where let x, that's just a variable that you've kind of said exists, but you've never given any value. So if you see undefined floating around as a value, that just means you're trying to use a variable that JavaScript has no idea what it does. You've never told it to do anything, so you need to like go back and figure out where you're going to set that up fully. And then null, you can see on the right-hand side, that's going to be assigned value. So you can either assign that yourself or some other function may assign it, but it basically means there's no value. It has nothing and it doesn't really know what to do with it as well. So it's pretty common to see null if you're assigning a function return to a variable and that function doesn't return anything. So that's just kind of another sign that you may have an error. So we'll jump into some of the other data types for now. So we'll start with numbers. So numbers is the main kind of like math and arithmetic data type. Many of y'all may be familiar with integers, doubles, floats, things like that. In JavaScript, really the main kind of mathematical type we're going to be using is numbers, and that can include any decimals, positive, negatives, and all integers and real numbers. The other thing included in the numbers type is infinity, negative infinity, and non or not a number. If you're going to see these, they're going to appear exactly as we have them written on the screen there. So it's going to appear as the word infinity or negative infinity. And if you see any of these three, that pretty much means your code is broken somewhere. So infinity and negative infinity come up when you've done some kind of math that has gone beyond the bounds of what JavaScript can handle. So it's going to be if you're in some kind of infinite loop and adding or multiplying. And then not a number is going to be if you did some kind of bad math, like dividing by 0, trying to perform math on a string, something like that. So if you see any of those, you know something's wrong, and you'll want to go back and kind of check what your code's doing. And then JavaScript has the pretty standard math operators. So we got addition, subtraction, multiplication, division, exponentials. We have increments and decrements, which is just +1 and -1, respectively, to whichever variable you use it on, and then the remainder operator as well. So there's a lot of like more advanced math you can do in JavaScript beyond that stuff. One example, if you want to force a decimal to be an integer value, you can use the floor function or the math round function. Those are just two kind of brief examples to give you all an idea that there's a lot more math you can do with JavaScript. Obviously, we don't have time to teach you all a full math course in JavaScript, but there's a lot you can do with it. So next we'll talk about strings. So another aspect about JavaScript, you can write strings with double or single quotes. There's really like no difference when you're strictly using JavaScript between the two. The only time may one be preferential over the other is if you want single quotes in a string, you'd want to use double quotes to encapsulate that string, and vice versa. In your code in general, though, try and stick with one to keep things sane, so you're not switching between different types of quotes, because that's hard for people to decipher. If you want the length of a string, you're just going to use the variable name that you're holding that string in, .length, and that'll just give you the length property of the string. It's pretty straightforward. And then one really nice thing you can do with strings is you can print them using console.log. I'll talk a lot about console.log later. It's a pretty powerful function that you can use. And I'm sure you're all familiar with putting a print statement on every other line of code to figure out which line is broken. That's what console.log is in JavaScript. So you want to learn how to use this function pretty well. And then you can combine variables and strings using template literals. So basically what this means is if you want a variable to appear inside of a larger string, what you'll do to do this is instead of using the single or double quotes, you'll use the backtick. So it's going to be like the top left key on your keyboard. We have it on the screen there, but that just tells JavaScript that you're trying to put a variable inside that string. And then you'll use this formatting on the bottom of the screen there. Use a $, an open curly brace, and then the name of the variable, a closed curly brace. A lot of text editors will highlight that different colors so you can see it. But that'll just in this example, if you tried to print cool string on the bottom, it would say there are 24 in this room because it replaces the student variable with 24. So pretty straightforward, but that's really helpful if you want to display your data on screen and add some text along with it. So it's a pretty common thing to see in JavaScript. And then moving on to Booleans, these are pretty important. Obviously, just like every other language, they're true or false, and you'll assign true or false exactly as it's written on screen, just full lowercase the word true or false. And then falsy values in JavaScript include obviously false, 0, an empty string, null, undefined, and not a number. So these are important cases to kind of like understand where null, undefined, and not a number come from, because they can pass as false values and may like get through your code even though they're erroneous data types. So those are really important data types. Understand what they do and kind of keep a lookout for them when you're going through your code. And then truth values are just going to be everything else will be considered truthy. And then JavaScript supports your typical logical operators and or not. There's not an exclusive or in JavaScript, but that's something that you can get around with the normal logical operators. Okay, and then comparing values. This is another kind of like big quirk with JavaScript. So you can use triple equals or double equals to compare different variables and types in JavaScript. The difference is that triple equals is going to be type sensitive while double equals is not. So kind of as I explained in the beginning, all of our variables are loosely typed, which means they don't have actual types. And this is kind of where it bites us later down the road. So as we see, if we use a double equals to compare 4 and the string containing 4 like that, that'll evaluate to true. And if we use the triple equals, that'll evaluate to false. So the reason we want to use triple equals a lot is because a lot of times when we're comparing data, we want it to be type sensitive when we're putting it to databases. And if we're trying to like do any computations on it, if we're pulling stuff from the user as strings and then equate it with the number 4 as a string, try to do math with the string, we're going to break our code. So we need to make sure to use the triple equal sign on every comparison so that we know we're dealing with the correct data type. And then, yeah, like it says on the screen, it'll help you catch bugs because that stuff is going to flow through as being correct and you may not see it immediately because it still passes the conditional statements the way you want it to. And then there are other conditional statements, not equals, greater than, less than, greater than equal to, and then less or equal to.
Sweet. So moving on to arrays. So arrays are a little bit different from a lot of the other types we've looked at so far because arrays have dynamic link. That means there can be multiple values stored in one variable. So in this example, we let numbers be an array of 4, 9, and 12. And then you can actually go ahead and iterate through that array and access all of those differently, individually. You can also add elements to an array with the push function. So you can do the array name dot push and then a number and it'll be added. Arrays are ordered. So they have an index associated with them. So an array, the first element in an array is going to be index 0. And so if we wanted to get the number 10 from that array, we could do something like numbers. And then in the square brackets, we do 1 and that'll be the first position and that'll be 10. Some quirks about JavaScript is you can also use array destructuring. I don't know if this is actually taught in a lot of classes, but if you have an array, you can actually assign variables to those elements in the array through destructuring. So in this example, where we have let ABC equals 10 and 20, A is going to be equal to 10 and B is going to be 20. And then in JavaScript, you can also use the spread operator. And what that'll do is it'll dump the contents of one array into another. And that's best seen through examples. So if we look below, we let array 1 equals 2, 4, 6 and A2 equals 1, 3, 5. We can do A3 is equal to dot, dot, dot. And that's that spread operator that we're talking about. And so by saying A1, we'll actually put the contents of A1 into that new array at that location. Similarly, we can see that same thing at the end with the dot, dot, dot A2, and that'll put the contents of the second array in at the end. So spread operator is pretty useful. It's used in arrays a lot, and that's also how you just copy arrays. I know in some languages it's not quite as easy as this, but luckily it is here. And then we're going to move on to objects. Yeah, for sure.
So if on that last line you didn't use dot dot dot, would it just be an array of one element with the list as the element?
If you didn't use the,
If you didn't use a dot 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 on the last bullet point, so you just have A1 probably equal one element.
it would be like,
It would be like double.
it would be like a, yeah, it would be like a nested array. So it would be an array containing the array A1. And it also wouldn't like copy the values. So if you changed things, it would,
Oh, okay.
yeah.
And then moving on to objects. And objects are something that is very commonly used in JavaScript. And it is also an array that has, it's not an array, it's a variable that has a variable length. So that means it can have as many kind of variables inside of it. Jane Smith is going to be the pair. Objects are unordered, so it's not something you can actually like. You can't do student and then index on that student to get a value. Instead, you would do something like student.name to get Jane Smith. And it's really one of those things where you'll interact with a lot. I know we haven't quite talked about our database we're going to be using in our projects, but that's MongoDB. And that actually stores things in JSON format, which stands for JavaScript Object Notation. Oh shoot, there's another object slide. So we'll get into JSON in a second, but yeah, as I mentioned earlier, you can access a value in an object by doing the name of the object, and then you put that key, and that'll return you the value. So you can do student.name or student.age, and it'll return you the value. And then similarly, you can use the spread operator on objects as well. Another thing is objects also support that destructuring. And if you look at the examples, let year is equal to student, and then that'll get the year and set that equal to 2. So you can also copy objects using the spread operator like you could in arrays. Now we're actually going to go into JSON. And there's a few key differences between JSON and JavaScript objects. JSON stands for JavaScript Object Notation, but JSON is not actually specific to just JavaScript. It might sound a little bit confusing right now, but even if you think of these two as the same thing, it's not really going to cause you much harm at all. But yeah, so JSON is something that's supported by all programming languages. So in Python, you can do like, I think Python or .parse or something like that, and it'll actually put your Python objects into JSON as well. And it does that because all programming languages have some way of transmitting data over the web, and JSON is kind of a lightweight way to do that. And if we actually look at the example up there, you can kind of go between those two using a pretty easy function. To go from JSON to a JavaScript object, you can do json.parse, and to go from a JavaScript object to JSON, you can do the command json.stringify. And they're very similar, but there are just a few key differences. And one of those is that you can do more with JavaScript objects. So if you wanted to, you could put like a function inside of a JavaScript object, but you wouldn't be able to do that in JSON. And yeah, just a couple other notes about JavaScript overall is that semicolons are optional. If you want to use them everywhere. If you don't want to use them, don't use them everywhere. That just makes your code more readable. JavaScript also has if statements, for loops, for of loops, while loops, and functions. Those are all very common, but we'll actually go into a different thing you can do to do a lot of the same things in a minute. And when using multiple JavaScript files, you can import or export functions or variables. So you might have done something similar to that in languages like Python or Java, but you can actually import just functions or just variables, which is kind of cool. Similarly, if you're going to import a function or variable from somewhere, you have to export it from somewhere else. And yeah, imports are best at the top of the file and exports are usually at the bottom. I think that's demo time.
Okay, so before, before we hop in, do you have any like general questions about the syntax or stuff we talked about? Okay, cool. So I'm just going to do a super quick demo of just a couple of the things we talked about. There's a lot in JavaScript, so I'm not going to be able to demo everything. So I'll just give kind of a brief overview of what some of the more important things we talked about will look like. Let's see. Let's find this. All right. So first, I'm just going to go over to any web page, and I'm going to right click and inspect element. So I hope you all have kind of caught on at this point, since we talked about it every day from here. But inspect elements is going to be a really helpful tool for you all when we're developing stuff. So it's a really good thing to know how to use. So I'll be using that today for the demo, just to show you another way you can use it. So here we've got just our HTML again. This is stuff we've been talking about last time. We're not going to touch any of this today. So we're actually going to go over to console here on the top bar and zoom in a little bit. So what the console is this is how kind of your JavaScript is going to communicate with the browser a little bit. So a lot of times if you get error in your code, you get warnings in your code, or you're printing stuff with like console.log, like we were talking about earlier, all that stuff will appear here in the console. So this is one place you can view those errors and see kind of what's going on. Another thing the console does let you do is you can type code directly into it and run it. This is never a way that you'd want to actually develop because you're not really doing anything with this JavaScript, but I'm just going to kind of show you a few of the things we talked about today in the console. So first we can start just by declaring a variable. So I'll just say let x equals 4. Like we talked about, I'll zoom in a little bit. Okay, so let me move on to the next line, and I'll just demonstrate one of the most important functions, console.log. So if we call console.log, whatever we put in between the parentheses, it's going to print to the console. So go ahead and run this, and you'll see it just prints the number 4, which was our value of x, to the console. And it'll say undefined after everything I type, just because I'm doing this in the console. It wouldn't normally do that when you're running stuff. And then, oh. Okay. So now we can do something like x equals 5. So like we talked about with putting variables inside of strings, we can go ahead and print this variable inside of a string by using our backtick. And we'll put our string inside of the backticks. So if we want to say the number is, we go ahead and use the $, open curly bracket, close curly bracket, and then I put x in between them, and that's going to put the variable x where that symbol is located. So we go ahead and run this, and it'll print out the string, the number is 5. So it's pretty straightforward. So I'll talk a little bit kind of about the JavaScript objects now, because that's one of the more important things that you'll be using a lot once we get into project teams. So we go ahead and write an object the same way that we just wrote that variable. So we can declare a variable x equals, and we'll start off our object with the open and close curly brackets. So we can add our first key value pair to the object. We can actually call this student so that we kind of know this object we're talking about. So a student would have a name. So we'd go ahead and give it a name. We can call this student Cole. So we go ahead and put a comma after our first key value pair and move on to the next attribute. The student may have an age, something like that. So we can give it a random number for an age, and we can mix and match data types. We could put anything we want in here. We could nest other objects if we wanted to. I'll go ahead and nest an array in here as well. So a student object may have an array of classes. So we can go ahead and declare an array with our square braces like this. A class may be CPE 357, and a really fun one. And another one may be columns 101, also a fun one. So this is our student object, and now we can access these variables with the notation that Cole mentioned earlier. So if we go ahead and console.log, we want to print the name, we just go ahead and do student, which is the name of our variable, and .name, which is the attribute we want to access. Go ahead and hit enter, and we can see it prints out Cole to the console. So another pretty powerful thing with console.log is if we're dealing with more complex data structures, so like this object, for example, we're not limited to just printing like individual attributes of it. So if I want kind of a more overarching view of what this student object looks like, I can just put the name of this object in console.log. I print it out, and it's going to give us some really helpful information about this object. So it's a really easy kind of visual way to look at your data and see kind of what's happening. So we can expand kind of this notation it gives us, and you'll see it kind of gives an outline of all the aspects of this object, and it gives it an alphabetical order as well. So we've got the age value that we assign to it. We have its array of classes, which we can further expand. It gives the index and the value along with the array, along with the length. And we have the name of the student as well. It'll give us this prototype object thing, just telling us that what we're looking at is an object. We don't have to know anything much about that. That's just kind of how JavaScript handles it behind the scenes. But yeah, that's just a really helpful way if you're dealing with these more complex data types and you can't really understand what's going on. That's a good visual representation to use if you're feeling a little bit stuck. So the last thing I'll go over is just kind of the triple equals sign. So we have let x equals the string 4. It's pretty common to pull in data in string format, but we're not really going to want to do any kind of computations with this. So if we had an if statement that if x equals 4, and if that's true, we'll go ahead and console.log true, so that we can see what happens. So we'll see that this expression evaluates to true, right? Because we have the string data type and we're only using the double equal sign to compare it. And that's a really bad error that we don't want in our code, because pretty common data type to interact with is strings. And if we're trying to do computation on a string, we're just going to break the website. So the triple equals is a super simple and easy way to fix that. So it's just a good habit to get into, just always putting triple equals with every comparison. So I went one line too far. Oh yeah, so now it'll not evaluate to true. So we don't get any output from that. So that's just a few kind of simple examples of the stuff we talked about. Can't really go like a whole overview of JavaScript because there's just too much to discuss. Are there any kind of questions about what I went over, or any other questions from the slides that y'all have? All right, cool. You guys have anything else?
No, you covered it.
All right, sweet.
Okay, so now we're gonna go over functional programming, which is kind of like the programming philosophy that fits really well with JavaScript. So similar to, if you know object-oriented programming, that goes really well with Java. Functional programming goes really well with JavaScript. So here's like a quote about the philosophy of functional programming. Functional programming, which is often abbreviated FP, is the process of building software by composing pure functions, avoiding shared state, mutable data, and side effects. And then functional programming is declarative rather than imperative, and application state flows through pure functions. So that's kind of a big jumbled word. So we're going to kind of break that down right now. So a pure function is a function where if you put something in, it will always give you the same output. So if I have this function called add7, where I put in a number and it gives me like that number plus 7. So if I put in 3, it should always give me 10. It shouldn't be like, it will give you 10 on like Wednesday, but then it, like on Thursday, it gives you 11. Like the output should always be the same if you're getting the same input. Similarly, avoid mutable data. So this one's a kind of hard habit to break, but essentially what this means is try to avoid changing data as much as possible. So that means making lots of copies. So if your function takes in an array, instead of like changing that array directly, instead maybe try making a copy of that array, changing it, and then returning that new array. And what that allows is like weird side effects where the programmer puts like a function, like expects their variable to stay the same, but then it doesn't. And then finally, be declarative and not imperative. This one we're going to get a bit more into later, but really what this means is write code that shows what you're doing and not how you're doing it. So I think the best example of this is a for loop. Like if you show a for loop to anyone that's not CS, they're going to look very confused because the syntax isn't very clear about what's actually happening. So that in JavaScript, there's better ways to kind of write code that's more concise and clear about what you're actually doing rather than how you're doing it. Okay, so now functions in JavaScript. So we're going to go over like the 2 ways you can write functions in JavaScript. So on the left here, you'll see kind of the traditional way to write a function where it's function, then the name of the function, then in parentheses, you're going to have 0 or more like inputs. And here we just have X. Then curly brace, you have a whole bunch of code, and then a return function, or not a return function, a return statement, and then closing brace. So that's how you traditionally write. But in JavaScript, more often than not, you're going to see this thing called an arrow function. And what an arrow function does is it kind of takes the function syntax and makes it look more like a variable. So here we're going to see const add7 equals, and then the parentheses is pretty similar to a regular function. And then we have this arrow. So input is on the left of the arrow, and then you have your function code on the right of the arrow. And that's pretty much the same. But arrow functions also like to simplify things a lot. So if your code has 1 line, you can get rid of those brackets. You don't need them anymore. If it has more than 1 line, you definitely need to keep the like curly braces before and after. And you can also do this thing called an implicit return. So if you look at that first example of an arrow function, right here, there's like the return keyword, but here we just got rid of the return keyword. And it's just X plus 7. So that last statement which is like your only statement in this case. That's what the function's going to return. And then finally, if your arrow function doesn't have, if your arrow function only has one input, you can get rid of the parentheses here too. So parentheses, no parentheses. So you might see a variety of these different syntaxes. It takes a bit of time to get used to, but just be aware that these are all ways that arrow functions kind of change the function syntax and can kind of make that like 3-line function and cut it down to like 1. Any questions about that so far? Okay, so now we're going to get a bit into using functions as values. So the nice thing about arrow functions is since their syntax is so concise, you can actually pass those functions in. Well, first of all, there are functions where you can pass functions in as input. So this is like weird to think about, but if you look at this first example, like there's a.find, and that's like a function that you're calling. And in that input to a.find, you're putting a function. And that function is that arrow function arrow x greater than 7. So you're kind of treating this function as a value you're passing directly into another function. So here's like some examples of common functions that take functions as inputs. You have find, and all these deal with arrays, but there's lots of other functions that don't deal with arrays as well. So there's find where you pass in like a function, and the first time that function evaluates to true, that's like the value it's going to return. So if a equals the array 5, 2, 10, 8, you're going to call x arrow equals, or x arrow x greater than 7. So if you pass 5 in, is 5 greater than 7? No, you reject it. Is 2 greater than 7? You reject it. And is 10 greater than 7? Then you accept it, and that's what that function is going to return. So you're iterating through that array, but the for loop isn't actually visible to you, if that makes sense. The function inside of that find function, it's going to like iterate for you. And then a couple more ones, find index. It's similar to find, except you're returning the index instead of the actual value. Now, this one's going to be used super common, and we'll have plenty more time to go over this. But essentially what it does is it takes each value and applies a function to it. So the first value of a is 5. So we're going to use that arrow function and add 3. So now this new function it's going to return. This new array it's returning, the first value is 8 instead of 5. So also notice how this is not using a mutable array. Instead, it's returning you a new array. So after you call a.map, a is still going to be 5, 2, 10, 8. But a.map is going to return this new array called 8, 5, 13, 11, where each value is 3 greater than the current value. And then filter, what that does is it iterates through the array and it removes all the values where like that expression evaluates to false. So that percent operator called the modulo operator that finds like the remainder. So if x is modulo 2, is going to check if the value is even. So in this case, filter is removing all the odd values from the array and returning a new array. Okay, so here we kind of have like a setup question. So we want to have you try applying these new like functional programming skills in order to solve this problem. So the first line of code you're going to have is going to be let prices equal this array. And what I want you to do is write a piece of code that will log like a new array that follows that question. So you're going to take the array, you're going to discount all the prices by 20% if they're less than $10. And then if any of those values are less than 2, you remove it from the array.
And while you're doing that, you can use the console. You can just search like JavaScript compiler online. Whatever you feel comfortable with works.
Yeah, if you just Google JavaScript console online, it will give you plenty of results. The console is also a great resource. Don't worry if this is tricky because arrow syntax and all of these things take a while to get used to. This is like the big difference between JavaScript and a lot of other languages. And feel free to raise your hand if you have any questions at all.
I don't think so. Yeah.
Stop hearing it.
I'm really crumbling.
Feel free to talk with your neighbor too if you have any questions.
What's killing that feed? It's got to be a wait. I learned the question. Yeah. Yeah.
You have to,
You have to do the math first.
right, because then you have to remove everything.
Yeah, that's it. Yeah.
Oh,
there's
yeah.
multiple
It's a
steps.
new. Why is
I think the right answer is to just do it by hand and then print the new, right?
If you can either do like a statement or a ternary in the back. Yeah, that's the setup. Or at the same time, it's a good learning.
It'll make sense once you explain it.
Yeah, exactly.
It's a really good explanation of functional programming. I feel like it made like pretty clear sense.
Yeah.
It's like really abstract.
Yeah, I think it's even more abstract than object oriented because object oriented, like this is an object.
Oh yeah, no, for sure. It's way more.
Functional programming, it's a bit more than this is a function, you know.
Yeah.
I think like the mutability thing is like the real key. That's where it's like your functions aren't just changing variables. They're giving you new ones. No.
it's new under two? So we want to remove. I think it's just that, right?
Try to be too quick.
So. What is it? Is it comma? Not arrow function.
I don't know.
It's weird on the console. Like I would never do this on the
No,
console.
it's terrible on the console. Like doing the demo is so stressful.
Syntax, yeah.
I don't know.
Yeah, I don't know if this gets qualified.
Where's here? And not do
What's
the
the-
console log yet.
What part of it doesn't work?
Well, yeah, there's one-
Technically, you don't even need to console.log,
There
right?
it is. Wait.
But that's not right.
You
Oh,
got it. I
flip
think you
flip the
reversed it.
conditional on the filter, I think. I think you're filtering out everything that's,
Sure, yeah. Oh, wait.
you added the console.log back in.
Oh my goodness. Why is it not?
You can't directly log an array. Doesn't know what to do.
There we go.
Huge.
Oh, yeah, that weird thing. Yes.
You click a dot find index inside of your dot map while you're a dot find index inside of your like prices dot map. Maybe it's easier if I just look at your code. Same code.
I don't think you could
So,
Yeah.
put a find index inside of map, because you'd be on an individual element or inside of map, right?
Yeah, so I guess, hey, you might
Unless
be
you're
able
passing
to.
in a two-dimensional array.
So my recommendation would be two steps. Where first you discount
I think it is one of the things that
go
is.
back through the array.
Dot find, yeah, it's gotta be two.
Yeah.
I guess you could maybe do this, maybe. Find the prices
I mean, if you want to be
equal
first
to
about it.
two. Yeah, there we go. So, I guess you can. Well, I guess you could.
The conditional. So. So you.
Wait.
Like, you know, when you write it.
It might have broken it and use X twice.
It's just gonna be the big L, the parentheses, that's gonna be what's to the right of the arrow, because you can just do an implicit return.
They don't have to be prices, right?
So I would just put the X.
Yeah, I just mean, oh, I see.
So I think it's the right thing. It's just you can't do this because it's returned. Oh, wait. Let me try this.
Oh, okay, I get your question. So for arrow functions, you can either do brackets, which allow you to just write it regular statement,
Yeah.
or you just do the ternary operator, or you can that'll allow you to do it in line, but
So it's just making it.
yeah, so I would just do brackets there, it'd just be like if X greater than
Yeah.
return.
I don't know.
Yeah. Like, I would just make it more concise, and I'll show you when we go through it, but
Yeah.
sometimes more concise also makes it less.
Yeah.
Especially after.
How much you have left here? What was that? How much is left? This is it. This is the last one. Yeah. Later. We should go ahead and show the answer.
Yeah, I think we can go ahead.
All right, drum roll.
Okay. Okay, we're gonna go over the solution now. So if you were doing this with regular for loops, it would look kind of gross. This would be the code. So you go through the array, check if the value is less than 10. If you do, you update it so it's 20% less, which is that multiplying by 0.8. And then in a new array, you would go through prices again now that the prices are updated. And if the price is greater than or equal to 2, then you add it to like the new prices array. Does that solution make sense using for loops? Okay, so that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines. If we did this with arrow syntax, you can do it in 3. So let's take this step by step. So this first for loop, you just go through and you take the value and update it to be 20% if it's less than 10. So in this map function, we take a price. Yeah, thank you. I can't reach that high. And this first conditional is going to be, is the price less than 10? I'm never going to use this thing called the ternary operator, which I wrote down over here. This is kind of small, sorry if you can't read it. But the syntax for a ternary operator is A is going to be an expression, question mark, another expression, colon, and then a third expression. And essentially what this boils down to is if A, then you would return B, else return C. So this is kind of a way to condense down an if so it's more declarative, less. I'm not sure if it's declarative or imperative. It's the one that's better. If you wanted to put an if statement, what you'd want to do is you just use brackets and write it like a normal function. And just put the brackets where this piece of code would be, put the if state conditional, and then just have two return statements. But with the ternary, you can get it down into one line, and you'll have the conditional is price less than 10. If it is, then it's just going to return price. If it's not, then it returns price. Oh, I misread that. If it's less than 10, it returns price times 0.8. If it's greater than 10, it just returns price. So that syntax also takes a little bit of time to get used to, but it's really concise and really clean if you do get used to it. And then you can actually chain these operators. So after the map, this map is going to return a new array. And on that new array, we're going to call filter. And for filter, we're going to just take in the price. And if it's greater than or equal to 2, we keep it in. Otherwise, we just toss it out. So that is how you convert a very large piece of code into a much more concise functional programming approach.
Sweet.
All right.
So that's kind of gonna be it for today. This is a sneak peek of what we're gonna look into next time. We've learned we learned this new language, JavaScript, and it's kind of cool to know, but it becomes really powerful once you combine it with the HTML and CSS stuff. And that's where you really get interactive websites that can start to do a lot of things. And that's just what we'll be covering next time. Move past these slides and go to the just updates. So yeah, just back to the updates. Milestone 1 is due tomorrow at midnight. Us three will be here until 8 today. So we encourage you guys to use this time, get help if you need it. Even just, it's a good time to work on it. Get as much done as you can. There's also gonna be that pumpkin patch social that's happening on Saturday. It's early morning. There's information about it in the Slack. Love to see you all there and get to know you guys like a little bit more. These bootcamp sessions are great and all, but they're not that personal. So coming out really like lets us get to know you. And is one of the great things about Hacker Impact is there is like the community events as well. And then yeah, the membership fees, please. Everybody's gonna get a shirt, and like a lot of the membership fees will cover these shirts. It'll also do things like cover server costs and other things. It just really helps our club. If you can't afford it, that's fine, but we do encourage it if you can. But yeah, that should be it for this week. I guess any questions about anything? Sweet. And I guess that wraps it up. You guys are free to go, but we do encourage you to stay and work on your project and get some help if you need it.